Hey there, this is Mr. Wolf. Shout out to all my Geo peeps. Today we're doing Geometry Benchmark 11 Triangle Congruence Criteria. The Common Core standard for this benchmark is right here, G.co.8. The way I'll structure this video lesson is the first half, I'm just going to show you and explain to you exactly how these different criteria work. And then the second half, I'll have some notes pages up for you to copy down that are easy to read and understand. So for this first part, if you'll just pay close attention to what I'm saying and showing, I think that'll help most, and then you can copy the notes down at the end. So what we're talking about is proving triangles are congruent. You'll remember that congruent figures have the same shape and same size. The way we prove congruency is by mapping one figure over the other using a series of translations, rotations, reflections. In these two figures, you can see that these two triangles are congruent, and the markings tell us. For example, this side with 3 tick marks is congruent to this side with 3 tick marks, and this red angle is congruent to this red angle, and so forth. Okay, so we talked about what it means if they're congruent. For triangles to be congruent, though, we got to have all 3 sides congruent to each other, and all 3 angles congruent to each other. And again, that would look something like this, where each of the corresponding sides are congruent to each other. And then the same with all 3 of the angles, too. Okay? So here's our original image, and we can match them up. A goes with D, B goes with E, C goes with F. Side AB goes with side DE, BC goes with EF, and CA goes with FD. And that should all make sense because that's what we've been doing in class. The big question is, though, I mean, that's 6 different pieces of a triangle. We don't have to prove all 6 corresponding parts are congruent. Yay! That means less work for us. Instead of proving all 6 parts are congruent, we have some shortcuts, and that's what we're going to learn today. All right, the first shortcut that we've got is called the SSS shortcut. That stands for side, side, side. Let me show you a quick demo of that. So here I've got 2 triangles, and they've set each of the lengths to be congruent. So ED equals AC, AC and ED are congruent, and so forth. I want to try to make this quick. We can check and see if they are congruent triangles, and here's how I'm going to do it. I'm going to take point D and drag it on top of C. Okay, remember, all these sides are already fixed. The only thing I can change is the angles. Okay, so I'm going to change this angle here to match up with A. Oops, I need to move this up first. Move this down to A, and then move this to B, and F to B. And are the triangles congruent? Yes, they are. In fact, this is the only triangle I could make with these 3 sides. So we don't have to prove the angles are congruent, because if the sides are congruent, then the angles are also all going to be congruent. There's only one triangle you could make, and it's this one right here, congruent to that one. Okay? The next one is the angle side angle criteria. Okay? So that's saying that we're given an angle, a side, and an angle, and the side has to be between the 2 angles. So this is our given triangle, and this is the triangle that we're going to make congruent. Okay? So you can see we're given this angle, which matches this one. We're given this side E, which matches C, and we're given angle E, which matches B. All right, so I'm going to drag point D down here to A to check for congruence, and B here. All right, so everything here matches up. All right, and then what I would simply do is I would have to stretch out those side lengths. Whoops, excuse me. I'm trying to grab this one. There we go. It's not letting me. There we go. Okay, all I would do is stretch out these sides here. And there's only one triangle that can be formed, and that's the congruent to this triangle. So we know that if we prove an angle, a side, and an angle are congruent to another triangle, then the triangles are congruent to each other. Okay? The next one we learn is side angle side. Okay? So this time we're given 2 sides and the included angle. That's an important term to understand. That means the angle is between the 2 sides. You can't just pick any angle. It's got to be the one angle between the 2 sides. So if we drag D over here and put it on top of C, okay, and we rotate point E here, you can see it stays the same because that angle's the same. All right, so given this side length, this angle measure, and this side length, there's only one triangle we can draw, and it's going to match up with the same congruent triangle. And you can see how that would work there. Okay, so those are the three main criteria for determining that triangles are congruent. Again, all we've got to do is prove all three sides are congruent, an angle, the included side and the angle, and the side, angle, side. There's actually two more that we want to add. These are a little different. This one is AAS, so you probably guessed that's angle, angle, side. All right, and so if you'll watch here, we start with, whoops, let's go back. Start with a point, add another point. We get an angle and an angle. And so since this one's angle, angle, side, we're going to go angle, angle, and then we'll add a side. It's not included this time. Okay, so given these criteria, there's only one triangle you can make. It's that triangle right there. So we're going to do the same thing over here. I give you a side, give you an angle, give you another angle. Do the angles match over here? Sure they do. Does the side length match over here? Sure it does. And of course, there's only one triangle we can make. It's that one. And the following angle has to be the 77. And these triangles would map on top of each other. So AAS works as well. The last one is what we call HL. HL stands for hypotenuse and leg. This one's kind of a special case. It only applies to right triangles, triangles with a right angle. All right, so you might be a little confused at this drawing right now, but if I rotate that there, okay, now we've created a right triangle. And so H is the hypotenuse. The hypotenuse is always the long side of a right triangle or the side opposite from the right angle. And a leg is just one of the other two sides. So if you're given a leg and a hypotenuse and a right angle, then there's only one triangle you can make. Okay? You might be wondering if there's other ones that work. Like sometimes people will ask about the ASS theorem or SSA theorem. Either way, it doesn't work, and here's why. Let me show you a demo here. In these, we're given an angle. They both have 31 degrees. We're given a side. They both have 7.3, and we're given another side because it is ASS, angle, side, side. The last side is 4.9 and 4.9. So at first glance, you might look at this and go, oh, well, they do make congruent triangles. Well, yes, these are congruent, but the problem is I can swing this around and make another triangle using the same angle, same side, and same side. So just because the angle side side works doesn't mean the triangles are congruent. So ASS does not work. There is no donkey in geometry. All right? And the last one like that, looks like this, and it's the same thing, SSA, ASS. It's just ass backwards. Pardon my French. Okay. Now let's take some notes. All right. Now that you kind of got a grasp on what it is, how do we find triangles are congruent? You can pause here and copy this down while I tell you exactly what everything means. Triangles are congruent if they have the same three sides and same three angles. But what we've learned is this today. We don't have to know all three sides and all three angles. Usually just 3 out of 6 is enough. And these are the 5 ways we can do that. Okay? SSS, side, 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 angle, side, angle, side, angle, 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 side, and HL. Okay? So I'm going to go through each one of those and let you copy down the notes. Here we go. Here's side, side, side. All 3 sides are congruent, so you know the angles are also congruent. You can pause, jot that down. Make sure you include a picture in your notes as well. All right, side, angle, side. If a side and the included angle, okay, that's key, included angle, that means between the 2 sides, are congruent to the other triangle, then we know the rest of the parts are also going to be congruent. Angle, side, angle is just like that last one, except an angle and an included side. The included side means it's between the 2 angles. Pause and get that down. Then we talked about AAS. Angle, angle, side. So if you got an angle, and then one more side that's not included, the 2 triangles will be congruent, as long as those parts are congruent. And the last special case was with right triangles only, so make sure you get that down. You will rarely see this Okay, but if you do see right triangles, the first thing that should pop in your head is HL, and you should test to see if HL works. So if the hypotenuse and a leg are congruent to the hypotenuse and leg of another triangle, then we can assume that the triangles are congruent as long as they have that right angle right there. Okay, I hope you got all that down. If not, just go back, pause, and copy all this information down. We don't use angle, angle, angle. It might seem like, oh, that's one we would use, but here's what a problem that occurs. This triangle has 40, 30, and 110 degree angles. This triangle has 40, 30, and 110 angles. Are these two triangles congruent? Well, I hope you can see that they are not. This triangle is bigger. So just because the angles are congruent does not mean that all the sides are congruent. Without knowing at least one side, we cannot be sure if the two triangles are congruent. All right, so this kind of wraps up where we are. In class, you need to bring in a complete sheet of notes or sheets of notes. There's some good practice on Khan Academy. So if you go to Khan, if you Google Khan Academy and type in triangle congruence, this is the kind of stuff that pops up. He's got videos over here that are similar to mine. If you didn't understand mine, watch one of those. And then all the activities with stars, those are going to be things that you can actually do to practice, okay? So take an active role in your learning and be an active learner, not a passive learner. Active learners are actively seeking new knowledge and trying to get better. Passive learners just sit there and expect the knowledge to be put into their brain. It doesn't work like that. And last, as always, if you have questions, please email me or you can text me at this number. I hope all that made sense. I'll see you in class. Peace out.